Hello, welcome to Rue's Astro Workshop. Well, actually, welcome to Rue's Garden. Um, we're going to go in the workshop in a minute, but I thought because it's such a nice evening, we'd start off outside. It's nice to get out, and especially when we're all stuck inside. And I'm fortunate enough to have a garden, so I thought I'd come and use it to make this intro. Um, a few months ago, I purchased something I've been looking for quite some time, which is um, a tapping head, and this is a made by a company called Ackworthie, who were uh, in Kenilworth, and obviously haven't made them for a long time, but you do occasionally see them come up on eBay and such like. But this was from the local auto jumble. Now, when I saw it, I knew straight away that it was a tapping head, but I didn't recognise much about it. But that was the whole thing there. So it was the tapping head, but it had no collets, and it didn't even have the nut which compresses the collet either. So the, there are a few other bits missing. There's a torque bar missing from there and a stop which goes in there. That's pretty easy to sort out. So what I had to do is make a collet and a compression ring, which is there. And well, what this video is about me making those, and also investigating how this sort of basically works, and also whether it was worth modifying or whether I needed to make these parts to make it work. Um, it works in the range of well, I think it was an imperial range originally, but basically from small, like 2 or 3 mil, up to about 6 mil or quarter inches, its maximum capacity. So I've opted to make the first collet I've made is an M6, which is 6 mil shaft. So because I thought if that's the biggest one, I'll see if it works with the biggest tap. Now, for those of you that don't know much about these tapping heads, they work very simply. They go in the mill. When you turn this shaft, it actually reverses the operation of the head itself. So I'm turning this clockwise, and this shaft is turning anti-clockwise. Now, if I actually put pressure on there, so as if you were to bring that down in the actual drill or milling machine, then it goes in the same direction. So every turn that I do of that turns that in the right direction. So as you plunge the head down into a hole to be tapped, it will be the machine will be driving the tap into the hole. At the point where you reach the full depth of your thread, or you go through, you run through the other side, then you relieve pressure on the machine, which allows this to drop, and at that point it reverses. So in this position, the shaft is then reversed, so that has the effect of pulling the tap out of the hole. Now, some of you may or may not have seen those work before, but they are actually very expensive. The modern ones are not cheap, and even used ones that I've seen before have been very expensive. This was very inexpensive, simply because there were bits missing. But I've gone ahead and made a collet and a closer for it. So let's go and have a look how I did it. So there are a couple of options open to me here. The first option was to possibly look at replacing the actual output shaft. So because I haven't got any collets or the collet closer, what I figured is that I could use an ER11 collet chuck and shaft. And if I could remachine the shaft on the collet chuck, I might be able to replace the output shaft. So what I'm doing here is I'm taking it apart to see how it actually works. Now, what you can see here is there is a shaft, but it's slightly more complicated than I at first thought. And the shaft itself has a couple of, I think there's two dogs rather, dogs on the shaft itself, and the shaft itself seems to be hardened as well. Now the way that it works is you can see that the shaft moves up and down depending on whether you're driving it in or out, and that either engages on the pulley on the wheel, which is on one side, or it engages on the other. And depending on which one it engages depends on the direction that it travels in. So now I've established that that's too complicated. I figured that making some collets and the locking ring would be the way to go. So what I'm doing here is just measuring and doing a drawing and measuring up all the critical dimensions. This is a small hole gauge, which is just a sort of expanding ball, which you, by tightening the top, you can make it fit, and then obviously you use an ordinary micrometer to get the size. And I did that so that it was a sort of just a nice fit inside the shaft. So the theory being that the collet would be snug, but a nice easy fit. And this is just measuring the depth of for the length of the collet itself. That was a little bit tricky as well, because it seems that the original collets didn't go all the way to the end. They just sort of stopped a bit short. So I tried to sort of estimate what that might be and created a drawing. So off to the lathe and machining this is the actual collet itself. It's a piece of silver steel, drill rod, as it's called in America. Silver steel, which is just a high carbon steel, and which is reasonably hard already, but can be hardened if required. It machines very, very nicely. Here I'm using a Tom Lipton chamfer tool to face the end, put a chamfer on, and then I'm also creating a small undercut, which is for the actual collet, the large end of the collet. I find this tool ever so useful, and I use it increasingly over most of my other tools for very, very quickly if you need to face a part and turn it down and chamfer it all in with one tool. It's a great tool. I'm so glad I made it a long time ago. So I'm now drilling just starting off with a center drill and drilling the hole for the collet itself. This is the collet I'm making here is an M6, so I drilled and reamed the hole to 6mm, although I think reaming is probably overkill. Just basically drilling it, a reasonably smooth drilled hole is absolutely fine, because the actual collet gets split with a splitting saw into 4. So the fit itself is relatively arbitrary, as long as you can get the actual tap in okay, and it's a reasonably snug fit, then the collet will actually compress down onto the shaft of the tap itself and grip it pretty effectively. So just using the center there, and then a couple of different drills just to get down to size, finishing off with the 6mm. I'm just testing the actual 6mm M6 tap in there, and it's a nice snug fit. So over to the I turned it round in the collet and machined the other end, which was a fairly quick procedure, and now it's over to the milling machine, and using a collet block with the same 5C collet that I was using to hold hold it in the lathe. And this time it's in a square collet block. I'm just here slitting it with the finest, pretty much the finest slitting saw I've got. So there you can see I did 2 cuts right down, so it's in effect got 4 slits in it. It's actually 2, and then this is me putting the flats onto the locking ring. And unfortunately, I lost the video footage of making the locking ring, which is a shame, because there was some internal threading in that, which was a BSF thread, fine thread, which was quite interesting to do, but still fairly easy. Again, machined out of out of drill rod or silver steel. And I put a couple of flats on there to get a spanner onto, because obviously that's required. Again, using the square collet block. This time I didn't quite have the right size collet, so I had to force it into a collet which is slightly oversized, and they don't grip terribly well when you do that, so you have to be ever so careful and take very light cuts, because really 5C collets like to grip down rather than up. I could have used an ER32 collet, and probably should have done, because those have got a lot more range of what they can grip. 5Cs are really only meant for nominal sizes, and I didn't have the correct size for that particular part. So that's the flats on there, and I think just over to the vise now for a bit of fettling to take the edges off the last procedure, which just leaves a little burr. Before I do, just check to make sure that it's the size I was looking for, that I've got the flats correct. I think it's 3/4 basically. So everything on a Bridgeport is 3/4, as you know. Yeah, another thing you can operate with the same spanner. So just need to take those raggy edges off there. And silver steel is quite hard, so even though I'm using a nice sharp Swiss file, it still took a while to do. Anyway, this is the trial fit. There you can see it went in nice and snug, and this is the locking ring going down onto the collet, and the collet works absolutely fine. Those collets are actually pretty easy to make, and I'm going to make a full set for 6543 probably metric sizes, and I'll maybe make a couple of imperial ones that I do a reasonable amount of, things like 1/4 and this is me trying it in a piece of aluminium. So that was it going through a hole. Let's go to the next hole. You can see when you pull the lever down it drives forwards, when you let go it drives back again. So it's very, very quick. If you had a lot of holes to do, may really like work of them. I probably should have been using a spiral point there, but this is actually a spiral flute, but as you can see, works very well.